Welcome to the Alaska Level 1 lecture on mineral groups. So far, scientists have identified more than 3,000 minerals. Don't worry, we're not going to be identifying 3,000 minerals in class. We're going to be looking at the most common minerals called rock-forming minerals. They're called rock-forming minerals because they will make the rocks on the Earth's crust. The 10 most common minerals are the following. First, we have quartz. Quartz is a very common mineral found on the beach because it's very hard. Then we have orthoclase, plagioclase, muscovite, and biotite. These are all silicate minerals. We also have calcite and dolomite. These are carbonate minerals that will fizz with acid. Halite is a mineral also known as salt. Gypsum and ferromagnesium. Fe stands for iron. Magn stands for magnesium. So ferromagnesium atoms have iron and magnesium in them. Examples of these are olivine, pyroxenes, and amphiboles. These are dark minerals. Next, we're going to talk about mineral groups. The first mineral group are the silicates. This is the most common mineral group out of all the groups. In order for a mineral to be a silicate mineral, it has to have silicon and oxygen in its chemical formula. So quartz has silicon and oxygen. Olivine has silicon and oxygen. Biotite, muscovite, and feldspar will also have silicon and oxygen. Here we have feldspar, which is a silicate mineral, and just a quick review, it has a great cleavage. It has very flat planes. Mica is also very well known for having great cleavage. It breaks off into small flakes. Pyroxene is this dark mineral here. Quartz is a good example of having fracture, and olivine is a green mineral. Native elements have only one element present. In other words, they only have one capital letter in their chemical formula. So silver has one capital letter, copper has one capital letter, graphite one capital letter, and sulfur one capital letter. The next mineral group are the sulfides. Sulfides must have sulfur in their chemical formula. So galena has one sulfur. This is a very metallic mineral. Also has excellent cleavage. Sphalerite has one capital letter. It's a pretty color found in gemstones. Chalcopyrite is very similar to pyrite, which is fool's gold. Cinnabar has one capital letter, and this can also be found in jewelry. The next mineral group are the oxides. Oxides have oxygen and metal. So hematite, also pronounced as hematite, has iron and oxygen. This is a good mineral that has a streak of a reddish-brown color. Corundum is a very hard mineral, hardness of 9. It has aluminum and oxygen. Corundum is a hexagonal prism, so it has hexagonal cleavage. Magnetite is a magnetic mineral, and it has iron and oxygen as well. The next mineral group is the halides. Halides must have halogen elements, which means they must have chlorine, fluorine, bromine, or iodine. We'll be looking at two. The first one is halite, has sodium and chlorine. This is table salt, and it has excellent cleavage. Fluorite is calcium and fluorine. This is commonly mistaken for quartz. They often come in the same color, they have the same luster. The difference, however, is their hardness. Fluorine is going to be softer than quartz. The last mineral group is the carbonates. Carbonates must have carbon or carbonate in it. Calcite's our first example. It has calcium and carbonate, CO3. Dolomite has calcium, magnesium, and carbonate. These are both white. Calcite has good cleavage and it looks like a rhombus, so it's not at 90-degree angles. Dolomite is also white. Malachite is a green mineral, and azurite is a blue mineral. These are often found together. A lot of Native American jewelry is made out of malachite and azurite. The Statue of Liberty is turning green because it is oxidizing and turning into malachite. Crystalline structure. A crystal is a natural solid with a definite internal pattern. which means if the atoms are arranged in a cube, the crystal will be also a cubic shape. If the atoms are arranged in a hexagonal shape, the crystal will be in the shape of a hexagon. The silicate mineral group has a structure called tetrahedron. In a tetrahedron structure, there are 4 oxygen atoms arranged in a pyramid, and you have 1 silicon atom in the middle. There are 6 basic shapes. The first one, isometric or cubic, just means they look like a cube. We have all the orthorhombic, triclinic, monoclinic, hexagonal, which makes hexagons, and tetragonal. This concludes the Alaska Level 1 lecture.